So in this lecture, what we're doing is kind of covering the different techniques we use to find derivatives of functions. So the first thing I want to cover is what we call the constant rule. And what that is basically if f of x equals k, a constant function, that means f prime of x is equal to 0. Okay? Because a horizontal line is a constant function, the slope for that is 0. So if f of x equals 2, then f prime of x equals 0. If f of x equals 10,000, then f prime of x also equals 0. If it's a constant number, it's going to be 0, the slope. It's a horizontal line. If f of x equals pi, then f prime of x also equals 0. So the reason for this is that if you did f prime of x as a limit as h approaches 0, then f of x plus h minus f of x over h. You just have limit as h approaches 0 of k minus k over h, and that would all go to 0. That's the whole point. That's why. You just have two constants subtracting each other, it would all go to 0. So let's now talk about something we call the power rule. That's going to be very important for us to hack, for us to find these derivatives. So with the power rule, what we have is if f of x equals x to the n, then f prime of x is equal to n x to the power of n minus 1. You drop the n in front, and then you do n minus 1. Okay, that's what we call a power rule. Okay? Now, n has to be an element of real numbers, of course. Now, if we have f of x equals x to the 5, that means f prime of x has to equal 5x to the 4. You drop the 5 in front, take 1 away from the 5, so it would be 5x to the 4 as your answer. If you have x to the e, that would be e to the x e minus 1. If you have f of x equals root x, you'd have f of x be written as x to the 1/2. I drop that 1/2 at the front. F prime of x is 1/2 x to the 1/2 but negative. So that equals 1 over 2 root x as a derivative. Okay. There's something called the coefficient rule. Coefficient. So that sure rings a bell, doesn't it? Well, it sure does. The coefficient rule. We have set the derivative of r times f of x is r times f prime of x. That's essentially what happens. You take that constant out in front. So we just differentiate the function and ignore the constant that's in front of it. So if f of x equals 7x cubed, we don't get tripped up by the 7 right here. We do is f prime of x is equal to 7 3x squared, which is equal to 21x squared. Because you just drop the 3 down, and then n minus 1 is 2. But then 7 times 3 is going to be 21. if you have f of x equals 6 over x, nothing to fret about, that can be rewritten as 6 times x to negative 1. So f prime of x equals minus 6 all over x squared. That's how you write it. So if f of x equals e x to the pi, with pi e to the x pi minus 1. That's what you do. And multiplication, you could do pi times e or e times pi. It really doesn't matter what order you do that in. That's how we do that. Let's talk about the sum rule. It's very similar to limits. You can add and subtract derivatives with each other. And you can do the same thing when we get to the part of the course that talks about integrals. So you have d dx of f of x plus or minus g of x. Then it'd be f prime of x plus or minus g prime of x. That's something to keep in mind. So if you have f of x equal to 7x cubed plus 21x, okay? That would mean that f prime of x equals 21x squared plus 21. Okay? Or if you had f of x equals 2x squared minus 7x plus 3, then f prime of x is equal to 4x minus 7. Okay? So, and then last but not least, if f of x equals 3x squared minus x plus root x, that would be also rewritten as 3x squared minus x plus x to 1/2. But you could write f prime of x, which is 6x minus 1 plus 1/2 root x. Okay. So, what about the product rule? Product rule is different. We can't just take the product of the two derivatives. It's not like addition and subtraction. There actually is a rule for when you take derivatives. So if you have d dx of f of x times g of x, right? It's not this. It's not this. That is not right. Let me show you. That's not right. Okay? No. No, no, no. That's not right. What is right is that we have a rule. d dx of f of x times g of x equals f prime of x times g of x plus g prime of x times f of x. Okay, that's what we have. That's actually tangible. So that's what we call the product rule. And you can prove it if you want through basically the definition of derivative. But that's like a mission and a half, and we'll kind of get over that. So if you have I guess I can prove it, I guess. So you have a derivative, d dx of f of x times g of x. The definition of derivative says it equals the limit as h approaches 0 of f of x plus h, g of x plus h, minus f of x times g of x all over h, right? That's step one. We're beginning this mission and a half of this proof. Usually make you do it in high school. They never make you do it in university. It's a waste of time because it's already invented. So it's f of x plus h, g of x plus h. So what can happen is you can add and subtract, basically, f of x times g plus h, plus you go like minus f of x times g of x plus h is a minus version, and you add it as well. Minus f of x, g of x. So you add and subtract and add the same thing, these two things in between, that's your trick. And basically, if you do that, you can factor out g of x plus h from here and from here. So you get limit as h approaches 0. And you can also factor out f of x from here and here. So you get basically g of x plus h factored out from so then, if you factor g of x plus h out, what you get is that this right here is the derivative of f of x, and this right here is the derivative of g of x. So all you prove is, hey, yip yip hooray. I guess what that means is when I put 0 in, I just get g of x times the derivative of f of x plus f of x times the derivative of g of x. Like I said, it's not what usually you have to do in university. I just did it for the sake of it as an academic exercise. The proof is kind of annoying. So let's actually apply it, because that's all that really matters on testing exams. They might make you do one of those proofs in high school. Not really my business. Let's see how many more pages we have in this note. We're going to get to quotient rule too. So we have f of x equals 2x plus 1 times 7x squared minus 3. You could really just FOIL this and just do a bunch of the power rule. You could. But we're going to do our fancy schmancy product rule. F prime of x equals the derivative of the first one. You leave the second one. And then you add the derivative of the second one, you leave the first one, okay? So what you get is the derivative of 2x plus 1 is just 2. So you get 2 times 7x squared minus 3 plus 14x times 2x plus 1, right? So then what happens is that you can go ahead and FOIL all this junk. Good old fancy math. So 14x squared minus 6 plus 28x squared, something like that, plus 14x. So you end up getting 28x squared plus 14x squared is 42x squared. And then you have plus 14x minus 6. Done. That's the derivative for you guys. We have another one right here. We can do that too for the road. So if I have f of x equals root x plus 3 times 2x squared, okay? Then we take derivative of the first one, d dx of root x plus 3, leave 2x squared plus root x 3x plus 3 times derivative of x, 2x squared, okay? What you're going to do is you're going to end up with 1 over 2 root x, okay? X squared plus 2x, whatever that one is. I should be, oh yeah, 2x and then root x plus 3. Then if you smash it all together, you would go ahead, you'd have 1/2 x to the 3 over 2, because you'd have 2 minus 1/2, which is 3 over 2. 2 minus, so 2 over 2 minus 1 over 2. Actually, 4 over 2. You have 4 over 2 minus 1 over 2. You have 3 over 2 right here. Plus 2x, root x. You can add those if you wanted. Plus x, 6x. So you would have had 4 over 2 from there, minus 1 over 2, which is 3 over 2. That's how I got the x to 3 over 2 over here. This is x to the 3 over 2. So now we learned something we call the quotient rule. So the quotient rule, just remember, there's like a song. It's called low d high minus high d low, all over low squared, all that fun stuff. So we have is the derivative, so d dx, okay, f of x, g of x equals low d high minus high d low, all over the bottom squared, all that squared. Okay. Low d high minus high d low, all over low squared. That's what the quotient rule is. So again, do not make up your own math. This does not happen. Let me show you what doesn't happen. This does not equal f prime of x for g prime of x. That's a no. That does not exist. That's so wrong, I didn't even bracket the rest of this derivative right there. You can't just take the derivative of the top and the bottom. That's not right. There's a formula. So if I had f of x equal to 3x squared plus 2 all over 2x minus 1, use a formula, right? Low d high, well, I guess I'll show my work, minus the high d low, which is, sure, I'll write it out, all over the low squared. So if you do all that, what you should end up with is you take derivative of 3x squared and all that jazz. If you take this derivative, which is 6x, and this one, which is 2, and you end up doing all your algebra, you should get something along the ballpark of 6x squared minus 6x minus 2 all over 2x minus 1 squared. So that's what you should get if you did all the FOIL and algebra. At this point, it's a game of algebra as opposed to derivatives, right? Thanks so much for watching, guys.